am I getting 1 comma and 0 comma? Where are those coming from? They're easy numbers to plug in, is where they're coming from. I could, if I wanted to, I could say, you know what? I want to have 2 and 3/17 to plug in. Do y'all think that that would be a nice, fun adventure? No. What about, negative 8.003604, comma blank? Would that be a nice number to plug in? No. So why am I picking 0 to plug in? Because it's easy. Why am I picking 1 to plug in? Because it's easy. We did start out these using the big T table. We went -2, -1, 0, 1, and 2, right? And then we condensed it a little bit because all of the graphs started looking the same. So I'm just going to pick, I don't know, I'll pick, say, number 1. So I have g at x. That's the same thing as f at x, which is the same thing as half, or y, right? Okay. So if we're going to graph that, first thing, do we have a horizontal asymptote? Yes. What is it? -6. -6. It's actually y equals -6 because y equals a number. Y equals a number is a horizontal line. Is that okay? We good there? Hang on. All right, so then now we're going to start plotting points. So we pick 0. That actually is where it crosses the y-axis. We pick 0 because it's easy, and it also crosses the y-axis. So I take 0, plug it in there. So I get 1/2 times 4 raised to the 0 minus 6. Yay? 4 raised to the 0. 1. Good. 1 times half. Half. Half minus 6. -5.5. Or -5.5. Is that okay? So 0, -5.5 is like down here. Right? Okay, then let's pick 1 to plug in because it's easy to plug 1 in. So I get 1/2 times 4 raised to the first minus 6. 4 to the first is 4, right? Half of 4, 2 minus 6. So that's a -4, right? So 1, -4. Take it. Wait, 1, -4 down here. So this goes and does this. Is that growth or decay? Growth. Now, someone else was asked, hey, how do you know what this graph looks like? They all look the same. This, you pick the 2 points to indicate where the graph is going. I mean, would it make sense if I had on a linear equation, let's say I had something like this, I'm just making this up off the cuff. If I had these 2 points, would it make sense for our graph to do this? No, we haven't seen that, have we? Would it make sense for our graph to do this? No. Would it make sense for our graph to do this? Well, we're making the graph. They all look the exact same. They have the exact same curve. They either go up or down, but it's the exact same curve. So this kind of gives you the direction where it goes. Yeah.
So that graph right there, would that be a decay because it heads towards the...
No, it's growth because as I go this way, it's growing away from the asymptote.
Oh, the asymptote. Okay.
If it was this, it would be decay because it's going towards. Make sense?
Yep.
So there's just these little curves. They're subtle little curves. That's all it is. And you use 2 points and you just kind of do the best you can, making the curve come out of it. Have we had any graphs like this that we've done? No. So would you expect to see it on a test? No, I hope not. He's not here. Okay, so just be cautious on this. And then the last one I want to just run through real quick, just to refresh memories, would be like, let's take a look at number 2. Number 2. Is number 2 an exponential function? It's linear, right? How does he know that? Because it doesn't have an exponent that is x. Okay? So where's across the y-axis? -5. How do we know that? Well, that's y equals mx plus b. I have a slope up 2, right 3. Connect the dots. Done. Okay? Good? Happy? So page 31, 32 will be due on Monday, okay? So finish it up. Okay? Tuesday? Oh. What? What page was it again? Number what? Which one? Yeah, it could. You could have that. So plug zero in. It's done the exact same way.
Yeah.
There's no difference. Order of operations. Take care of the exponent first. 2 to the 0 power is 1. -2 times 1 is -2. -2 added to 1 is -1. Plug 1 in. 2 to the first. 2. 2 times -2. -4. -4 plus 1. -3. Done the exact same way every time. Okay? We good? Content? Let's close.